Warm greetings from Jaya School of Architecture. I welcome you all for the 19th session of this DECODE series. Today, we have a very interesting topic for presentation and discussion. The topic is on Thoughts on Office Design by Architect Nicholas. Sir is here along with us. I now hand over the session to Bhavya ma'am, our faculty team, to give the welcome note and the welcome address for the participants. Over to you, ma'am.
Thank you, ma'am. As Kavita ma'am said, today is the 19th session of our DECODE webinar series. Before we start with our topic and the incredible speaker that we have today, I'd like to extend a warm welcome to our Dean, Professor Anita ma'am, our Director, Professor Kavita ma'am, our mentors, Architect Satish sir, and the audience today. Our speaker for today is Architect Nicholas sir, who has been working as an architectural consultant and as a client-side architect for the past 25 years. He started his career with architect B.V. Doshi, and with whom he designed the office spaces for the diamond merchants in Bombay. He is very much interested in the use and implementation of computer technology such as BIM and Revit to design, develop, and document and represent different architectural ideas. He is a strong advocate of sustainable design. He has successfully managed large architecture, SMEP, landscape, interior, infrastructure teams in the construction industry. He has been instrumental in designing, managing, and executing more than 1 crore square feet of office spaces, both in India and USA, from where he did his master's in the year 2002. One of his master's architectural design studio projects was also exhibited at the College of Architecture exhibition. His master's thesis, titled Architectural Representation and Interactive Digital Media Prototype, was published in the architectural magazine HSD. He also held a teaching assistantship at the University of Minnesota. Many of his architectural photographs have also been published in various books on and by B.V. Doshi and Professor James Steele of University of Southern California, Bernard Chiumi, etc. He represented India in a 15-day exchange program on energy and sustainable design in Tokyo for the Japan Society for the Promotion of Science. He has also given countless lectures on various topics like modern architecture in India, photography and architecture, energy policies, and sustainable design, ideas on representing ideas, etc. It is our pleasure to have you today, sir. But before we start, let me remind everyone that they can post their questions in the chat box and we'll get to them at the end of the seminar. Sir, please go ahead.
Hey, thank you so much for this introduction. Thank you, Anita, for giving this opportunity. Good evening, everybody. The title of today's discussion is Real Office Design. So basically, as Bhavya Madam said, I worked as an architectural consultant for more than 15 years. Designing various buildings, hospitals, offices, and malls, so on and so forth. For the last 10 years, I am in Bangalore. I'm working with developers as a client-side architect. When I say client-side architect, what we do is we, along with the developers, we appoint an external consultant to design the building we want to develop, and we evaluate the design. We coordinate with the external architects to make sure that the design is based on our standards or complies with our standards, and we help the developer in getting the right product that they desire so that the venture is profitable. So this particular talk I'm going to give from an office design perspective from a real estate developer. That would be the 90% of the talk. 10% I will bring in my architectural consultancy lessons learned. Most of the projects I'm going to discuss are a little bit larger offices, more than 1 lakh square feet. You may not be able to apply the principles in a smaller office like a 5,000 square feet office, but little bit larger, many principles will be applicable. I also understand today's audience, there are some are who are architects and some are academicians and some are students. So it was little bit difficult for me to compose a lecture to satisfy all these three categories. So please forgive me if some of these things are very simple and some are little bit harder to understand. Let's move ahead. So today's the content of the discussion will be, I broadly classified into three aspects. Let's discuss the pre-design aspect first. The pre-design is the things the developer does before appointing an architect or before giving the work to an architect to start the design. So this will include the feasibility study, the legal aspects of it, and to check whether this particular project will make money for the developer or not. If we are not going to make money, we won't do the project. Simple. So there is no architect in the picture. So this is the pre-design aspect is before the architects come into the picture. And the second is second topic, basics, is some of the things which I learned or I understood that will be good for the architectural consultant to know and understand so that they can give a better product as a first cut design itself. So now currently what happens is they will design, the architects will design and give us something which we may not like because of certain reasons. We tell them and they modify the design and it takes time. So these are some of the basics. It is nice if the architect knows. And the third is the interesting and maybe important aspect. Those are the metrics we use to evaluate the architect's design, or you evaluate the efficiency of the architect's design. Because if the design is not efficient, there won't be any money in the project, so there won't be any project at all, and then there won't be any work for the architects. So it's as simple as it. So the metrics part, which many developers use in Bangalore as well as all over India to evaluate the efficiency of the design, which is very important. And without that, many developers cannot even function. So let's talk a little bit about the pre-design. Like any other architectural office, we look at the statutory requirements for a particular land. So this will happen even before we purchase the particular land. A landlord comes with, say, a 4-acre property. We want to understand the potential of the property before even signing to buy the land. So we do all these things, like we do the statutory requirements, we do a small, simple design feasibility, and based on that, we do a costing analysis, and based on that, our finance team will do a revenue model, and if we make money, we do a go, or if the project doesn't make sense, we say no go, and that's the end of it. Even though it looks a long process, we do all these exercise in maximum 2 or 3 hours, because the number of landlords that come to us for doing a joint venture or develop a particular land is a lot, and we cannot afford to spend a lot of time on this. So let's talk about the statutory requirement. Like, as you may know, in Bangalore, we have a nice comprehensive development plan, which tells whether there is any nala in the particular land or a lake, or there is a cart path running through it, so on and so forth. If you are not aware, nala is the stormwater drain that is in Tamil. They may call it Vaikal or something like that. In a big city, we have so many such things. And there are regulatory requirements that you have to leave certain setbacks for these nalas or lakes. When I leave setbacks in my property, that constricts my development and it leaves out certain part of the area which I cannot build. So these things add a lot of pressure on the land and makes it impossible for me to achieve the floor area ratio, let's say FAR. So we have to be very conscious of this before purchasing the land. And the same goes with the road widening area. that the Bangalore Development Authority would say that this road has to be 45 meters in the future, but if it is only 20 meters now, I have to leave 15 meters from my property so that the road can be widened. So all these things are kind of a thing we have to go through it and understand this land before even starting the feasibility. When we do the feasibility, we do it in Excel, and we have a nice system where everything is set up in a way that I have to enter only the site area here. Like I have 4,000 square meters, it's almost a little bit more than an acre. Once I do that, and also I enter the permissible FAR, the Excel model itself creates a lot of data for me. For instance, here it tells me the permissible FAR would be 15,000 square meters for that particular land. However, when I try to actually design, it will be the potential of the land is only 12,000 I can achieve because of various reasons. The size of the property or the shape of the site, all those things. We'll just look at it in a bit. Like if the property, this is a live example. So if the property is shaped like this, I'm going to achieve only this much. And all these things the Excel itself gives without me having to do much work. And once this achievable FIR is understood, it can also find the required car parking for an office building. Once I know this, I have certain metrics which I discussed or I will discuss later on. I know the basement area, which is around 8,000 square meters of basement I need for this particular office building. And because I cannot have an 8,000 square meter basement in a 4,000 square meter plot area, I know I have to go for 2 basements. See, the way it works is it gives a lot of information for me to build on and go to the next stage. For instance, going down into basement in Bangalore is costly. Anywhere it is costly. So this will give me the cost factor. And the design FIR will directly link me or give me the leasable area for the office, which also will directly influence the revenue I can collect. So this small, simple Excel, see, I have hidden some parts of the Excel, but that can give a lot of information about how we can model it for the business plan of the...
I am sorry, there is a question for you on the sheet itself. They're asking you what POS means.
Oh, okay. I think you should not ask any questions because I think I'll run out of time. Okay. These are all the terminologies that come from the building bylaws. POS is for the parks and open spaces. So basically what happens is the building bylaw, if it goes above in Bangalore, in Chennai it might be different. If it goes above 5 acres, you have to leave say 10% of your plot area as a park. So open to sky space. In theory, it is supposed to be left out for the whole public. So anybody can come and walk in and use that space. In Bangalore, it doesn't happen like that, but that was the scenario. But if that has to be provided, then my buildable area becomes smaller. So that's why in this case, it says required parks and open spaces 0. Also, they require some amount of civic area. My intention was not to go into detail, so I was just trying to explain the broader aspects. So it will look like I'm going a little bit faster than required, but I want to finish everything in 30 minutes and give an overall understanding of how this interaction between architects and developers happen, and how architects can make use or make their designs or their interactions with the builders or developers better by understanding the underlying framework of the things. But please feel free to type in the questions. We'll come back. It's okay. I have all the time. I don't know whether the people who are attending the lecture have enough time or not. So that's the feasibility we do. As you can see, I did a very simple diagram here. We are not doing any massing. We are not doing any floor plan because I have only 2 hours to do this, to take a decision whether to buy this parcel of land or not. Okay, based on our study, this costing Excel sheet spits out the cost of the project. Basically, it's all formula driven. And in this case, if you notice the construction cost per square feet, we are saying 3245. This is not a random number. This comes from the metrics we will be discussing later. I will explain this and tie it back to this number. Basically, it says cost of construction per square feet is this much, so the total square feet is this, so this will be my cost of construction, and the land cost and the consultant's fee cost, so on and so forth. And as you can see, I have edited and hidden some lines because kind of this is intellectual property, we call it, so we don't want to put out everything there. So this Excel sheet basically gives me the cost of construction. This is 140 crores for this particular building. And once this number is there, the revenue model is a similar Excel sheet worked by the finance team. They will extrapolate the leasable area from my feasibility study, and they know in that particular area how much we can charge per square feet, and they can come up with the revenue model that would say that much revenue they can generate per month, per year, and in 10 years. And we will figure out the break-even period. So once we are happy with that number, then we decide to go with the purchase of the land or not. So this whole set of things happen in 2 hours or 3 hours, and this is the pre-design part of it. And once that is done and we are very happy and to proceed with the architect, then we appoint an architectural consultant along with structural, mechanical, electrical, plumbing consultants, so on and so forth. Currently, the company I'm working for, we like to do the design in-house. So what we do is we decide to buy a parcel of the land. We actually don't do just feasibility. We just complete the concept design as well as the schematic design, incorporating some aspects of the structure, mechanical, electrical, plumbing. We call it SMEP in short. We do that. And we also have in-house renderers who can create not photorealistic but amazing views that we can understand and feel the project. So this is one of the office buildings we are currently designing. So once the architect is on board or we also do it, these are the basics we are trying to hit. And this is not the basics, the vehicular circulation, size, organization and all. It is not a standard per se, but these are the things that is nice to follow in an architectural design or architectural planning for an office building. Let's look into each of these topics in detail. This is a different project. This is a 40-acre land. The subplot is 40 acre. It's a big project. So as you can see, 40 acre will translate to 40 lakh square feet of office space. Okay, and that would mean there will be 40,000 employees working in this particular project. Okay, that 40,000 employees will translate to 8,000 cars. So 8,000 cars is a huge number, and in an office design, typically all these cars come like 8 to 10 a.m. in the morning. So in 2 hours, all these guys will come in, then the cars are parked. And again in the evening, in a span of 2 hours, all these guys will exit. So the traffic is crazy. In a 40-acre project, it is really, really bad. So the best way of dealing with that, what we found is we have the entry, then directly you take all these people down in a 2-lane or 3-lane ramp into the basement. So once you do that, 90% of the traffic on grade is just vanished. Everybody goes into the basement, and from there they go to park under the tower, or they go to the second basement, third basement, so on and so forth. So the idea is to have the parking ramps as close to the entrance. So you cross the security, your screening is done, and then you directly go down. That doesn't mean there won't be any other ramp in the project. There are like a couple of other ramps here and there, but the entry ramp next to the entry will greatly reduce the traffic on grade, because you have traffic on grade for a lot of buses. If it is an IT company, they usually have a lot of buses to bring their employees, so they will be mostly roaming around on grade. So that will, if you have cars also, it will be held there in traffic planning, so we try to do that. Let's talk a little bit about floor plate. Most of the office buildings developers do are basically speculative in nature. When I say speculative, that means when we start the design, or sometimes when we start the construction, we don't know who our client will be, who will be leasing the building. We won't know, like whether it will be Microsoft or IBM or Apple or any other smaller second level companies. We don't know. So we have to design in such a way that it works for many of our potential clients. In Bangalore, what we have realized, the ideal floor plate is just the footprint of the building, is to be around 10,000 to 25,000 square feet. The reason is, if Microsoft is coming to my project, they will just take the whole building. They will not take floor by floor. But there are only around 10 or 20 such big companies in Bangalore. So if those guys, beyond that, there is a lot of mid-sized companies. There may be 200 mid-sized companies. And these guys cannot afford to take the whole building. They would like one floor. In that case, their range is between 10,000 to 25,000 square feet. If it is 50,000 square feet floor plate, if I try to design a building, these smaller companies cannot take the whole floor. So they may have to share the floor with some other company. In that case, they don't like it, because then they may have to share the toilet, they may have to share the AHU room, the air conditioning, the so on and so forth. So Bangalore, the ideal scenario, Bangalore as well as in India, the ideal scenario is 10 to 10,000 square feet footprint. Okay. So basically it is market dependent, market driven size. But when we design a 40 lakh square feet office space, we have to have variations. So we try to keep it in different, like we even go to 35,000 square feet, floor plate, so on and so forth. And all the companies really like rectangular plan. I know architects, we don't like it. We want to do a fantastic design and things like that. But this is because mainly most of these companies, like take any big company, Accenture or IBM or anything, their facility management team is headed by a civil engineer. Usually, nothing against civil engineer, but they like things to be rectangular, where they can imagine how they can keep their office workstation, how things can easily be managed. If you do a little bit irregular building like this corner one, they are hesitant to lease it. So the chances of leasing a building increases dramatically if you keep it as a rectangular building. And also the another point is the 3 or 4 grid width. The width cannot be too much that the natural light is difficult to get in, and it cannot be too thin where the internal planning becomes very difficult. So the optimum width of the floor plate has to be 3 or 4 grids. We'll talk about the grids in a bit. Structural grid, I mean. This one building, we did it in a little bit crazy shape, because this is on a very busy road here, and we wanted to create a signature building. And eventually that developer wanted to have their headquarters there. So that is one of the reasons that we took a little bit of privilege and designed whatever we wanted. This is a plan of a wing of one particular floor plate. This doesn't have much to do anything with developers. This is the office we designed while I was working as an architectural consultant. I wanted to show this because it has certain aspects that may influence the design of any office building. This project was done, I think, 15 years back. Usually, offices will have cabins along the exterior. Cabins mean for senior managers or CEO. CEO would get the corner office, so on and so forth. And this we did for an American company called Express Scripts, where we flipped the whole paradigm. So the common people, the commoners, or the workstations are arranged along the exterior so that they get natural light. And because the workstation is not floor to floor, it's a desk basically, the natural light still comes in, and these are the cabins. So the senior managers also can get natural light. This is a little bit different than the typical way of doing office. So in this scenario, we arranged all the workstations along the exterior, kept the core, that would mean a staircase, toilet, storerooms, so on and so forth, in the center, and the cabins and conference room in between. Another interesting thing we did also to create privacy corners or a smaller conference rooms where only 3 or 4 people can sit, where a person can go and take a phone call. See, in a large open office, that is a big problem because somebody will be talking to his wife, rather fighting with his wife, and you have to sit next to that person and listen to the conversation. So we created this privacy corners where people can take their calls in a private conference room, small conference room, and then they don't have to disturb the whole crowd. We also created an idea of separate zones, like if you are a call center kind of, if your work profile is kind of a call center or a BPO where the noise is not a big problem, you will be sitting in a bigger space. Where if you want to do a little bit focused work, even though you're sitting in an open office, you will have a different space. Can people see my mouse? I'm moving it here and there. I'm pointing it.
Yes, we can.
Okay, thank you. And also, if there is some work where you may have to collaborate with others and still you want to focus kind of thing. So we created these multiple zones where the noise level is modulated based on human behavior. So that we did in this floor plate. Another big complaint that came from the client was that they were saying, based on their past record, at any given time, there are only 75% of the employees in the office. The 25% were either on leave or they're sick or they were traveling for meetings or outside work. So they were saying, if this is the scenario, can I make my office building itself smaller so that I can spend less for the capital expenditure? So we did some analysis and we also came up with something called hoteling workstation. So a person will not have a fixed desk in the office. You come to the office and based on your work for that particular day, whether you are interacting with a particular team or you want to do a focus work, you go and sit or occupy a particular workstation. Any workstation that is available, you can do it. Everything is computerized. You could do it on the computer. You can schedule it in the computer, and that will automatically reroute your telephone extension line, so on and so forth. And in 15 years back, we had those telephone extensions and so on and so forth. So it worked out pretty good for the client. Again, this is not particularly related to developers, but I thought I'll share it because it had some concept that people are doing it now. Excuse me. So this particular slide talks about the core design. See, in an office architectural planning, if you do the core perfectly, and the basement, which has a lot of services, chiller plant, pump room, and electrical room, so on and so forth, your design is done because everything else is just a grid. The core design we give a lot of importance because anything other than the core is leasable area for the developer. So we want to maximize the leasable area as much as possible to generate the maximum revenue. Okay. So the idea here is, where do I locate the core in a building? Say if this is my building outline or a footprint, whether it is beneficial to have it at the center or I locate it along one of the sides. Both the options have pros and cons. You can take a decision as per your site condition. But in our case, if I keep the core in one of the sides, it blocks the light. So that I feel is not a good thing. When I do a floor division, if I have smaller tenants who want, say, 1/4 of this floor, who wants to lease only 1/4 of this floor, it is easy to divide in a situation where the core is at the center. I don't have to have any extra corridors. Whereas if I want to divide this into 4, I may have to run a corridor like that and then divide it into 4 or 5 aspects, separate tenants. So when the moment I put in the corridor, that becomes non-revenue generating area. So we don't typically like it. So in that case, the central core seems to be better. For elevation also, having a core like this, if you want to have a fully glazed building, this kind of scenario will make it a little bit bad thing. One bad thing about having this core at the center is you will need ventilation for your toilets, and you need fresh air for your AHUs, lot of things. All these things have to be brought from the roof via huge shafts. So that will cost you a little bit extra, as well as it will take up space from your floor area. Luckily, that space is not included in the FAR calculation, but these are the pros and cons. And this one illustrates the office building that has the core at the edge. As you can see, the glazing, we cannot wrap around the building fully. Let me get into a little bit detail about the core. As you can see that it contains this linear lobby in this particular core. You have passenger elevators, there are 4 of them here, and then there is a service elevator along with a fire tower. This is the requirement by the fire authorities. And you have toilet, male, female toilet, and a handicapped toilet. So these are the things mainly makes up the core. You have an electrical room also, and some places they may have a communication room separately, which brings in all the telecommunication and the TV, internet, and all the cables. We want to design this as compact as possible, so that I increase my leasable area. And one of the metrics we use is that it should be around 5 to 10%. It cannot be more than that. It should not be more than that. That would mean that it is an inefficient design. So this is the same core where I have highlighted only the shafts here. Shafts are these big openings where we run the ducts or pipes or cables. In this small office, we have all these shafts. PHE is for plumbing, so that will bring in water supply and take out sewage. Pressurization shafts, we have many because that's a requirement by the fire authorities. For instance, staircase, and this is one of the pressurization shafts. During fire, air will be pumped through this, and the pressure inside this staircase is increased than anywhere else, so that the smoke cannot enter the fire escape stairs. People don't die by getting burnt. Most of the time they inhale smoke and they die. To avoid this, the fire authorities require this. So we have a pressurization shaft for this staircase, another one for this, and 2 for this lobby. These are the fire requirements. And then we may need STP shaft and the DG flue shaft, so on and so forth. This is rain water downtake pipe. The roof water, we want to take it down and save it in a rainwater harvesting tank. So we need all these shafts. I don't want to go into the detail of it, but the idea is all these shafts, when we design also, it has some certain relationship. As I told you, the pressurization has to open into this fire stair, so I can't keep it anywhere else. Same way, the communication has to be accessible from outside, so it will sit here, and you get the idea. So it is little bit complex, but it is not rocket science. It is all basics. One of the main problems with this design is the MEP engineer who is supposed to tell us this is the shaft I need, and the shaft size is this, and these are the requirements for the shaft. Please incorporate it in the design. They don't tell us. While you are in the middle of the project, at that time they'll say, no, I have a DG, I need a flue pipe. You want me to leave the flue outside your building, or you want to take it all the way to the top and leave it in the terrace? So at that time, you can't leave it outside. It looks ugly. It looks like an industrial building kind of look and feel. So we have to take it into the building, and the only way to do it is the core, and this is where it ends up. So these are the things that comes late. So this is one of the reasons that in our company, we do the design in-house, because we can control all these things. In our past, when we give this work to external architectural consultants, for some reason, maybe they are busy with something else, they don't get all these things checked. So suddenly when we are about to start the construction drawing, somebody will say, oh, I need this DG shaft or STP exhaust shaft, let's do it. So that creates a lot of problem, especially because then the core becomes bigger, my leasable area becomes smaller, so on and so forth. In this particular slide, let's talk a little bit about the grid size. When I say grid size, is the distance between the columns. The structural guys try to do this. In any office, every 50 square meter of the FAR area, I need to provide one car park. So the number of car park is enormous most of the time, and we have to do it in the basement, 1 or 2 basements, and most of the time this increases the cost a lot, and it makes the project unviable. So this is a very important aspect, unfortunately, and based on our experiences, we have realized to design a basement, 30 square meter per car parking space is needed. Okay, so but if we don't design it properly, it will end up like 40 square meter or 50 square meter. In that case, my construction cost becomes very high. What we have realized is, if you keep the distance between the columns around 7,500, I can stack 3 cars, which is each is 2,500 millimeter based on the bylaws. Bylaw says I need a car parking space of 2,500. So if you exactly fit that 3 cars within this grid, it makes it it results in a very efficient basement system. So we like to do this fit 3 cars or 4 cars. In that case, the grid center to center of the column grid will become 10 plus meters, and both will work. The 8.5 meters for 3 cars and 10.5 for or 11 meters for 4 cars will work. But we also have to look at how the office above sits within this grid system. So there is always, we have to see whether the office workstations will fit within this 7.5, 7.6 meter scenario, as well as the cars. Luckily, in this case, the office workstation is 5 feet by 5 feet, which is like 1.5 by 1.5. That's a standard thing we work with. So 5 of those guys can sit within the column without much problem. So kind of this works for our office floors in the upper floors as well as the basement. Abroad, what they do is they do the column grid based on car parking in the lower floors, and they put a really thick transfer girder or a slab, and then the column structure entirely changes in the upper levels, which will suit the office layout. But that costs a lot of money, and India, that's one of the reasons Indian developers don't do it. Also, our NBC doesn't like it, so the structural engineers are very hesitant to do that. So the structural engineers want to do one column in the basement and take it till the rooftop. They don't want to change anything. That is so, but in this case, the 7.5 meter grid will work for both. This is a very small detail. Like as you can see, I have set the columns inside the parking spot. This is because when we reverse the car after parking the car, you reverse it to take it out, the car turns a little bit here, and if the column were in this red spot, it will hit it. So you always push the columns inside by 2.5 feet or 750 millimeters, or 1 meter. The grid line can be shifted 1 meter inside. This is a very small, very basic thing, but many of the car parking, basement parking scenarios, if you go in Bangalore, they don't do it, and it is very difficult to take the car. So you become like a 3-point reverse. You go in, back, come back, go in, come back, and then do it. I think I'm going a little bit slow. I'll try to be a little bit faster. This thing talks about the edge columns. Typically, we do the edge column at the end of the building. This is the exterior, this is the interior. We like to keep it 1 meter inside so that the elevation can be free of any columns visible. This is one way of doing it, but you can also bring the column to the exterior and create interest by doing a separate elevation. In our scenario, we try to do this. This also reduces the height of the spandrel panel. I'll just explain it in a bit. This is a cross section of the building. These two lines represent the column. This represents the glazing. This shows the drop panel of the concrete flat slab, and this is the edge slab condition. This is the false ceiling line. In this particular office building, we wanted to have full vision panel. In this, typically in other offices or other buildings, they do a spandrel panel which will be opaque and it will hide the other side of the false ceiling as well as the structure. So in this, we try to push the column in so that I can get a very thin structural edge where my false ceiling can go and meet, so that I can have the whole thing as a vision panel, not as a spandrel, so that I get more light into the office. The floor to floor height is again decided by, you need 9 feet for your clear space within the office, that is 2.7 meters. Then another 0.6 meters for the ducts, HVAC, AC ducts, and so on and so forth. And another 2 feet, 600 millimeters for the structure. That will bring you this number. So this is what they call a grade A office. So any big company in India, like IBM, Apple, or Accenture, they won't they won't lease any other building if it is not a grade A office. And one of the requirements is I need to have 4 meters floor to floor height. So while designing for developers, we have to be mindful of that also. That 4 meter becomes 4050 because fire stair riser is in the multiples of 150 millimeters, 6 inches. And the fire authority doesn't like to vary the size of the fire risers within the fire staircase. So we just multiply it and come to the nearest 4 meter, which is 4050. In modern days, we have to include all these spaces also in your office design: food area, cafe, gym, then library, creche also. Some people do it, laundry, dry cleaning, so on and so forth. This is the current trend. And another interesting thing we realize now is what they call as evidence-based design, where they attach a lot of sensors in the office building. They track when you come in, your car is tracked, the gate opens. When you go to your desk, once you log in, you are being tracked, and the light, ambient light, is tuned as per your liking. Also, the AC temperature is regulated based on your liking. If you are set on preset temperature, the temperature can be modulated based on these sensors. Even when you try to get a coffee from the coffee machine, while pressing the button, it can read your biometrics and add the sugar level that you set for yourself. So all these interesting things they are doing, most of them are not mainly related to architecture, but how IoT, Internet of Things, all those things are materialized. You can read this, The Edge Building by PLP Architects, for more information on that, but that's where the industry is moving. I'm coming back to the third part of the lecture. This is the metrics. Why do we need metrics or ratio? As I told you, this basic thing is to evaluate the efficiency of the design. So the architect gives me the design. I want to see whether they have done the basement properly, whether they have done the core properly. Just by this metrics, I'll be able to understand it easier. One. Second, if I don't follow the metrics, the project area is gonna go crazy. The leasable area may come down. The revenue generation will become different, and that may make the project non-viable, or everybody ends up in a loss. So let's just look at a couple of, there are so many other metrics, like for structure, MEP, everything. I'm just going to talk about only 4. We talk about this carpet efficiency. So it's very simple. Take the total floor area, take the carpet area divided by floor area ratio. That is the percentage number. For instance, a building that has 16,000 carpet area square meters, and the FAR area is 17,000. If I divide this, I get 94. That is my efficiency. That just says, here I have graphically tried to represent it. This whole, the orange color thingy is my brownish orange is my carpet area, whereas this becomes my core area. In this case, I have represented 90% efficiency. And as you can see, if I make the core smaller, my efficiency increases. So the revenue generation is more. And if the efficiency of this particular building becomes 80 or so, the project will definitely run into a loss. This one is about the leasable area. Leasable area is very easy to calculate. You get the carpet area into 1.5 times the leasable area. So in this thing, so this is what an office that is leasing will get. This is the area that we are loading in onto it. See, this is not a calculated ratio. This is a market-driven ratio. So this is the leasable area loading that the market will allow. If I try to load more, people won't lease from our building, they'll go to the next developer. So this is kind of the industry standard. The reason people are willing to pay more is because they also get to use the additional space of lobby, elevators, stairs, parking space, etc. Because parking space, the number of car parking spaces are tied to the leasable area. This we again discussed some time back. So basement area, I just multiply the number of cars into by 300 and check if the architect has done a good job. If not, they have to go back to the drawing board and redo, because 300 is a very easily achievable square feet per car. And this doesn't include only the car parking space. When I say this basement area, it includes everything, including the chiller plant, the fan rooms, the electrical rooms, the driveway that leads to the car parking spots, everything it is included. So that is how we calculate that. And this is the core efficiency. It's very simple, core area by footprint. So my footprint in this example, it is 2000 square meters. The blue area, which includes the whole of the core, is 400. So the efficiency is 20%. However, if I lease the whole floor to one tenant, then this AHU, the toilets will become part of their carpet area because they will be using it fully. So that becomes there. So when you look at only the orange outline for here, it is only 150 square meters, which brings my efficiency to 7.5. But the real efficiency is I have to remove all these cutout spaces for these elevators and the shafts. Then I'm ending up with 6. So in this case, the core efficiency is 6%, which is quite good. However, if you do a really tall skyscraper, like 30, 40 floor high, and if it is a very small footprint building, then the ratio can be very high. We can't help it because You need to have two fire staircase minimum. You can't do away with that. And because of this, the floor area, the core efficiency can go really, really high. Again, I said I want to tie back to this number. So why do we need metrics? As I told you, it helps us in the preliminary costing before we start the project itself. When I know the FIR number, just with the FIR number, I'll be able to calculate my basement, my carpet area, because based on the carpet area, I know how much revenue I'm going to generate. Everything is done based on that. So if you as architects don't follow or don't comply or don't stick to these metrics, it will put the whole project in jeopardy. This also easily will help me evaluate the architectural design, and also will weed out any mistake in the calculation, because architects are human beings and we are human beings. We make mistakes a lot of time, like just add a zero in the leasable area and the project looks fantastic. Those kind of errors can be easily caught when we try to check and calculate these metrics. Apart from this, you can, or anyone can talk about the integration of structure, mechanical, electrical, plumbing in the architectural design. That is a whole new topic. It will take at least 1 hour to even talk about it. And all these things are also considered, and we have certain metrics for all these things, like security design, traffic planning, landscape design, sustainable design, and interior design, so on and so forth. That has to be another place, another time, not today. Thank you. That's all I have. If you have questions, we can discuss.
Bhavya, would you like to shoot out the questions?
Yes, sir.
Quickly.
The core area which you talked about now, sir.
Sorry?
We have questions. We have a question saying, will that be a negative impact on the efficiency if we have multiple core areas?
Yeah, multiple core area can bring in, definitely it will reduce the efficiency. It is also not advisable if your floor plate is not too big. That's what I said. See, if your floor plate is too big, because of the fire distance, see, the fire authority wants the fire stair to be within 45 meters if it is sprinklered from any corner of the office building. So if your floor plate becomes too big, you need to separate the fire staircase. We had kept it very close, which the fire officer doesn't like, but it is allowable, so we kept it close. If your building becomes longer and longer, you may have to segregate it. The moment you segregate it, it will lead to a lot of efficiency problems. And if you split the elevator also along with it, the number of elevators required for your particular project may become more, because if there are 4 elevators in one place, people can then the waiting minutes or waiting time in seconds will be lesser for somebody to catch an elevator. The moment you segregate it, the waiting time increases, so that will lead to people not being happy. Also, whenever you bring elevator, separate the elevator, you can never have one elevator. It should always have 2 elevators in a grade A office. The reason being, if one of the elevators is under service, if I have another elevator, it will work well. Otherwise, I have a problem. And this IT engineers are amazingly quickly irritated, and they will paste everywhere, Facebook, Insta, everywhere, and that will be a huge news. So we don't even want to go there. The elevators will always be coupled two together. So that also will bring in that it will need its own lobby. Then you have to pressurize that. So everything will be kind of doubled.
Another question is that you are talking about different ambient zones, right, sir? So what sort of acoustical treatment will the core need?
Yeah, the acoustical treatment per se is not very much done in that place. The way it is that you are farther away, basically that floor plate is quite big. See, that was a building in the US. So US, they don't too much are not bothered about natural light because they have a lot of money. They can pump in, and they don't have any power cuts. So they will have artificial lighting like forever and ever. So basically, we are creating a zone in such a way that there is no physical soundproof technology, but it is just by the distance. And as you see, the core was kept in between, like the core had a staircase, storage room, and a lot of other things. With that, we were modulating the sound. Also, the employees, see, this was kind of interactive design with the client. Because I was part of an architectural consultant at the time, it was not a developer project. We made the client explain these concepts to the employees. So when they actually used it, if they feel that they may have to make a couple of phone calls, they were encouraged to automatically select the lower noise zone. So there were notices saying that it's grade 3 noise, grade 1 noise, and so on and so forth. So that will psychologically make people behave in a different manner. So that was one of the things we did.
Okay. I have some more questions over here. Why so much area for AHU alone? Can we keep it separated on an open balcony area? Asking due to ignorance. And can generators also be kept separately? Are they allowed in basements?
Yes, yeah, I like it. I would like to remove the AHU altogether. I don't want it at all. See, as an architect, see, this is the fight we have. As an architect, I don't want AHU. I don't want electrical room. I don't even want ducts. You just take it away. I want all leasable area. But in reality, how it works is the MEP engineers or the HVAC engineers, they want one AHU per 8,000 square feet of space. 8,000 to 10,000 square feet of office space, you need to have one AHU. AHU is not the chiller. Basically, it is just a fan. There is a chill water pipe coming to the AHU. The fan blows air into it and it becomes chilled air, and that is ducted and that is taken to the office space. So this guy, it is the, meaning AHU, it is better if it is closer to the place where it is servicing. You can also take the AHU all the way to the top. Then instead of bringing the chill water pipe through the shaft, which is little bit smaller in size, you have to bring a huge duct that will bring in chilled air. And sending chilled air for a very long distance is not possible in a duct. So if it is a, say for instance, if it's a G+2 building, I can have the AHU on top and I have to travel only say 10 meter and then bring it. But the amount of duct space, shaft space needed will become too much that it is not viable. It is also not efficient. So ideally AHUs, it's better to keep them in the same floor or as close to the area that is serviced. DG is another thing. DG can be kept in the first basement in Bangalore. In Chennai also the same thing, I think. So basement you can keep it, but the MEP consultant, the electrical consultant will not tell you that it needs a higher space to be kept first. So all our basement has to be at least 4.5 or 4.7 meters floor to floor to keep the DG. But the bad part of the DG is it needs a lot of fresh air to come in because of the way it works. So it needs a huge cutout next to it. So we keep it in the basement closer to the exterior wall. And if you see in any other IT parks, there is a huge mouth opening into this next to it where you get the kind of DG heat exhaust will go out. So it has to be very close to the basement. It can be kept DG even. This thing also can be kept in the basement. Basement you can keep DG as well as the I forget the word. The electrical transformers. Transformers also can be kept in the basement. It can be kept, no problem.
Thank you very much, Architect Nicholas, fantastic presentation. I
Thank
have
you.
no two words about it. I could see the precision of data and the meticulous practical nuances which you have gathered, which we sure don't get in college very easily.
Yes.
Until somebody like you come and share it. I think the children over here are more lucky than we were. And though I've been having a lot of requests from many people saying, please pass on the videos to us, please pass on the videos to us. I said it will be shared in March. I think yours is going to be a very sought after data, and I'm sure you're going to be called by many colleges also, because the nuances which you gave are something which most children need.
Yes.
Phenomenal data. I have no, I'm just like stunned with the meticulous way you put all the data and said only practical, only when you get into the field you get into this, and you have shared it all. Amazing. That is, of course, you have kind of focused a lot for offices in Bangalore, but I'm sure that the nuances with which you made your calculations will help them do it for their feasibility studies for their courses. Awesome presentation. Thank you so very much, Nicholas. And I think I have to thank Silbal and Satanathan and Ramji also.
Yeah. They were very helpful because I started with 50 slides and it went on. And these three people said that you may not need this, because I was carried away and was trying to put in more information as possible. But they helped me a lot to reduce the number of slides.
Yeah. So amazing presentation. And I'm sure this is going to be sought after. Don't scold me when a lot of people call you. Please be of service to the academic community. Please come more often.
Yeah, please send emails. Don't call me. It will be better if they text me or email me. I'll prefer that. I don't have any problem. I'll be very happy to help. Please contact me. Email is the best form of communication, because it gives me some time to respond. If you ask me something and think that I am an expert and I'll be able to answer, sometimes I may not. But if you send an email, that will give me some time to respond better.
Wonderful. So I take this opportunity to thank all the audience also who have patiently been with us. I did not want to interrupt Architect Nicholas because he was phenomenal. And I knew that all this mattered to everybody. And I'm sure there are many people who have decided they're going to see this later, because I got those messages. So I thought, okay, it is beautiful and everybody needs it. Thank you so very much. Thank you, Team Jaya, and thank you, audience. So we shall close the session for today, and we shall meet again.